Hello, thanks. Appreciate the introduction. Again, this is Rob. Just bear with me for a second while I share my screen. And can someone confirm you're seeing the full-size slide deck?
Yep, you're good to go, Rob.
Excellent. Well, thank you very much for the introduction. Again, my name is Rob Zimmer. I'm the Director of Cirrus and VDEX Deployment Solutions at Panasonic Corporation of North America. Really appreciate the time to talk to you all today about the Fleet Challenge and some vehicle deployment lessons learned. Today we're going to talk about, first of all, who am I and why am I here talking to you about this? Second of all, why you might want to engage your fleets with VDEX technology. And then lastly, I'd like to report on some lessons learned from some of our deployments, some things to pay attention to if you're going to go after installing VDEX technology on your vehicle fleets, because there's definitely some critical aspects that we've learned to help the process be as smooth as possible. So first let me address the question of what you might be thinking is, why is some guy from Panasonic, a company that makes TVs and batteries, talking about equipping vehicles for V2X? So our corporate mission is to improve people's lives and make the world a better place, as expressed in our brand promise of a better life, a better world. Making automobile travel safer and more enjoyable, reducing accidents and fatalities, mitigating congestion, and helping to protect the environment are opportunities that are very much keeping with what we've always been about at our core. So very consistent with our methods previously. You probably already know about the Panasonic name from microwaves and cameras and TVs and blow dryers. But we've been actually moving more into the business-to-business environment and business-to-government environment. In particular, when it comes to VDEX, really helping our partners in state governments deploy VDEX technology on the roadways to make roadways safer and more efficient. Most recently, we've deployed 100 OBUs in Colorado and 100 RSUs across 90 miles of Interstate I-70 into the mountains. As part of that deployment, we produced with our partners the first production-grade cellular V2X OBU, built, tested, and deployed on 100 fleet vehicles with CDOT. We have the first production-grade dual-mode cellular V2X and DSRC RSU, built, tested, and deployed in 100 locations. And this device is software configurable to be either DSRC or cellular V2X on that roadway, so no bucket trucks to convert those. And then finally, really the focus of Panasonic is building the next generation traffic management center software solution, which we call Cirrus by Panasonic. We built and tested that product and scaled it to be able to consume 100,000 simultaneous vehicles in range of RSUs to support the use cases for V2X. So that's really where our focus has been on VDEX technology here in Colorado, and why I'm talking to you today. So we'll move on now to why you might want to equip your vehicles. So why would you want to do this? There's really two main reasons. One is to start equipping your fleet to understand what is this new data source, understanding the flow of data into the TMC so we can begin to anticipate the use cases and applications that this data can provide. Really what BSM data and pro vehicle data from vehicles is really has a chance of revolutionizing how we're managing our roads. And we're really seeing this as an opportunity for state and local governments and entities to start building up their fleet knowledge and building up the understanding of what exactly is this data and how we might use it. The other reason is the standards do allow some fleet management with this technology using two-way communications that provides some identifying information in a fleet environment that's similar to AVL systems, but may have benefits of a single system that can consume that data and also manage fleets. This really allows for high-fidelity data collection, which is going to basically provide insights such as near real-time crash and incident detection, hyper-localized weather data, intersection movement data, as well as volume, occupancy, and speed data collection. And of course, there's endless other opportunities that could be seen for this. So we keep talking about data. What data? The SAE J2735 standard really outlines the message set, but we need to populate that message. And that data can come from cars. Today's cars have a lot to say, and this source of detailed, context-aware data will be critical for managing our roadways safely and efficiently. If you look at this graphic and you see all this data on this kind of outline of a vehicle, X-ray of a vehicle, you might think, not all the vehicles on the roadways have this kind of data. And 10 years ago, you would have been right. But today, most vehicles on the roadway have most of this data available on board. It's a matter of getting at that data and providing it as part of a message set to really enable the capabilities of V2X. So we do that, as I mentioned earlier, with the basic safety message, the SAE J2735 basic safety message. And for participation, all vehicles must broadcast this at 10 times per second. These messages enable safety-related applications on the road, but also add critical context to what's happening. Things like steering wheel angle, acceleration profiles, and airbag status. Way more than you can get off of traditional sources of data coming off of your smartphone that you carry in the vehicle. Working with OEMs to access this data has been a critical piece of the puzzle. And we've been working with OEMs, including Ford, to gain access to not only the core data, but also the Part 2 data, which really adds context to what's happening. Adding this Part 2 data to the broadcast really lets DOTs consume this data to understand what's happening and have context for what's happening behind events happening on the road. So continuing on why you should equip your vehicles, another reason is to better prepare to communicate with vehicles on the road. Once you're consuming data in, you can understand what's happening. That allows you to communicate to better situational awareness. It might be situational awareness for roadway operators and first responders. That's generally through cloud-based data analytics, TOC, TMC systems, such as Cirrus, but also get messages down into the vehicle. Vehicle operators are in the best position to make good or bad decisions depending on the environment. So we want them to have just-in-time, where they are information, allowing them to make better real-time decisions to avoid secondary, tertiary crashes, as well as to understand what's happening on the roadway in front of them, maybe beyond line of sight. Of course, I mentioned AVL as a potential use case. As I mentioned, the standards do support some identifying information as a DOT fleet when you own that fleet. And really, once you can enable vehicles for that, it really opens up a bunch of other additional applications. Thinking here, enhanced maintenance decision support systems. If you have equipped plows and you have micro weather data from vehicles running around the road or weather sensors, you can really make some really critical decisions for plow redeployment and re-engagement. Signal priority and signal preemption are also use cases where you can actually approve your fleet vehicles' priority or preemption of signals in order to complete their missions more efficiently. This really gains a lot of advantage because we're looking at one technology that can support all these use cases instead of having multiple technologies running around in the vehicle. So that's a lot of the reasons why you might want to equip. I'll talk a little bit about what's important when you equip. These are taken from lessons learned from our deployments with state DOTs, showing a little bit about some of the challenges and some of the opportunities that we've found. The critical one that we found for deploying vehicles as you're engaging fleets is that you need to understand schedule and have clear accountability and expectations. DOT fleets are busy. All vehicles are busy. They're expensive, and we want them used to meet the mission. So those fleets also can be even busier than their regular day-to-day jobs during incidents and inclement weather. It's been really critical for us to set clear expectations for the equipment installation process and schedule. We found it really important for us to make sure we're communicating clearly with the vehicle operator and the manager of those people to make sure that everyone understands what the plan is and everyone understands what the benefits of the program is for installation so that it can happen efficiently. The other lesson learned here about scheduling is making available substitute vehicles during installation. The installation process doesn't take seconds. It takes some time, and make sure that the people who are you're taking their vehicles have the ability of getting their jobs done in an otherwise manner. So we've identified that as a key engagement point as you are scheduling and creating accountability. Next, I'd call location, location, location. Geographic location and proximity to vehicle regular service and operational envelope is really critical. We need to make this process extremely simple and easy for the vehicle operators. Let them bring their vehicles in a way that is convenient. So we found that having diversity over locations for install is really important in order to make sure that we can make it as simple as process for the vehicles that we're targeting for install. As an extension to location, location, location is the location. The environment you're doing the installs in is really equally important as the actual location on the map. You may find a location such as the one pictured in order to install vehicles, but it's more than just the space. You have to consider environmental concerns. Make sure that the environment is good for the technicians and for the vehicles and for the technology. So make sure that you have heat and air conditioning available in the environment. Make sure you have protection from the weather elements of rain and snow. Critical that you have enough light in the environment. Critical that you maybe have supportive air if you need that for your vehicle maintenance. Enough power, and of course communications, whether that be cellular or Wi-Fi. All these are critical aspects of the installation location that must be looked at to make sure that you can provide a very efficient process that allows for quick turnover of vehicles to get them back on the road. The goal is to get as many vehicles equipped and back on the road as possible. I share this as an example of something we tried. This location didn't meet a lot of those requirements. We couldn't get an actual convenient location that was indoors and had all those requirements, so we made our own. This was a great location in Colorado for the drivers, but had a lot of limitations and other factors. It worked for us, but I use this as a case in point of lessons learned of make sure you do your homework on the proper location. This facility didn't survive very well in 70-mile-an-hour winds. Next is people, people, people. Make sure you have the right people to do the job. The proper skill set for scheduling, installation, and quality teams is critical. Proper cabling within a vehicle environment is not something any technician can do. You need technicians that have the experience to understand how to take a car apart, how to properly wire it to not cause additional problems, to make sure you understand the vehicle power and data systems to get access to power moding to turn off and not consume power when the vehicle's off, as well as how to get access to that really critical data. The data makes the VDEC system work, and without that highly valuable contextual data set, there's not a whole lot you can do. So it's really critical to do that. And in addition, also understanding that every vehicle make, model, year, and trim is different. So having that experience, having that flexibility to adapt to the needs is really critical for a successful install. Next, and probably the most critical thing, but I left it for last, is the actual onboard unit. The onboard unit you use really makes it all work. And you need to make sure that your onboard unit you're deploying meets the standards, of course. SAE J2945 and J2735 are critical. IEEE 1609.2, 3, and 4, of course, are also important. But there's other things to consider as you're deciding on an OBU to deploy. You really need that automotive-grade power management. You want to prevent that vehicle battery drain if at all possible. Make sure that when the car is off, it's consuming a very small amount of power, and when on, it turns on and transitions to an on state very quickly. Flexible CAN integration is critical. You need to customize each OBU to the host vehicle. Having a ability to have a flexible CAN integration that adapts to the vehicle that's in is really critical for, again, getting access to that contextual data. Something mentioned by Bob earlier is firmware over-the-air solution. You need to manage software on these devices. Recalling cars when you're deploying 2,000, 4,000, 8,000 cars is a challenge. You need to be able to support feature upgrades. and also to quickly squash bugs and security vulnerabilities as they're identified, because those are real things in the real world that you need to adjust for. Multi-layered security is critical, making sure you have security of the device, but also security of the messages being broadcast and received. SCMS solution for message verification and message signing is absolutely critical for a secure system. Finally, health monitoring. Remote health monitoring is critical. Understanding that the device is operating correctly, understanding that software installations and updates are installed correctly, making sure the OBU is processing data and sending out BSM messages and processing incoming messages is critical for the health of the overall system. So making sure that you have that basic health monitoring that you can see when things go wrong and basically be able to respond and fix them when necessary. And last but not least, our integration tools. It's fun to install a piece of equipment in a car, but if you can't guarantee it's working, there's not much point to that. So having tools that are able to consume the data from a vehicle and inject data via the DSRC or cellular VDEX antenna is really critical. The video shown here is a custom solution we built to consume a BSM from a vehicle and display very clearly to the text which parts of the basic safety messages are being populated and exercised. So they can go turn on headlights, change the steering wheel, change the gear, and make sure that all of the data is going from the beginning of the process, from the CAN bus, all the way out the antenna as far as a correctly conformed BSM message, but also that meets security. So these are really critical pieces to a successful installation event. All this is to really drive DOT understanding of what's happening on the road. We are working to develop with Utah DOT a solution for the next generation transportation management system. Cirrus by Panasonic is really the way we are collecting all of this critical data to basically be able to take immediate action on critical roadway conditions, sensing directly from the roadside, from those vehicles themselves. It's critical that we have this context-rich data set and that vehicles are deployed in a way that meets all the standards. This is me. Happy to answer any questions here at the very end. I think I'm going to pass the baton back.